Hello everyone, I'm GangQiang from USTC China. I will introduce our system on predicting emphasis in presenting slides. The purpose of this shared task is to design automatic methods for emphasis selection, that is, choosing candidates for emphasis in presentation slides texts. To enable automatic design assistance in ordering, and show in the picture, the words in the left slide has the same color and font. Thus, the audience needs to read the slide from beginning to end with all their attention. However, the important words on the right are emphasized with different colors and fonts, which can guide the audience to focus on a few words and retain their attention to the speaker. Actually, the task on predicting emphasis in presenting slides can be formulated through a sequence labeling problem. The major challenge of the task is that the dataset provided is collected from a variety of presentation slides with different topics. Besides, different annotators has different standards, as their understanding to the texts may be different. Thus, the characteristics of the dataset requires our model to have a good generalization ability. The dataset provided is collected from a variety of presentation slides with different topics. Each instance presents one slide page alone with annotations. The data is randomly divided into training, development, and test sets for further analysis. The detailed analysis of the datasets is shown in Table 1. And here is the description of the BestMatchm. This is the picture of the development of Transfomer-based language model. As we can see from picture, as recent years have witnessed the rapid development of language model. It is shown that natural language process tasks such as entity recognition and reading comprehension can achieve better performance by pre-trained language models. As we can see from the pictures, but as the milestones of the development of language models starts a new era in natural language processing. After the BERT was proposed, many variants of BERT is proposed, but can be pre-trained unsupervisedly on a large amount of unlabeled data by several strategies such as masked language, and next sentence prediction. After the release of BERT, a number of transformer-based language models are proposed. XLNET combines the advantages of aggressive and auto-grading and proposed a generalized aggressive language model. ERNIE, which was proposed by Baidu, combines the advantage of the aggressive and first consider the word structure and the semantic label information in training corpora by incrementally builds pre-training tasks, and then learn pre-trained models on these constructed tasks. ROBERTA proposed new methods to train in BERT and achieves better performance. Our BERT is a light version of BERT, which decreases the number of parameters and while retain the performance of BERT. Here I will briefly introduce our system. As illustrated in the figure, we use BERT-based pre-training models with a fully connected layer. The input of our system are sentences, and the output are the scores of the sentences. At first, the tokenizer of the corresponding BERT-based pre-training model convert the sentences into tokens. Since the length of the sentence and the length of the tokens are different, the start indexes of each token are also recorded for the later computation of the final score. The token indexes are the input of BERT-based pre-training model. We use the pre-trained models in Hugging Face transformers and fine-tune them in the datasets that the task provided to better extract the semantic information of the sentence in different levels. All the output of the layers of the pre-training model are concatenated. We also observe that the words start with capital letters. Capital letter often gets a higher score, and the word containing special characters often get a lower score. These lexical features are also concatenated with the output of the pre-training model. And finally, they are fed into a 3-layer feed-forward network with dropout in the input of each layer except the last layer. The output of the feed-forward are scaled to by a sigmoid function. Finally, we can get the score of each words. We use PyTorch as the deep learning framework and Hugging Face as the pre-trained language model framework. All the experiments are executed in NVIDIA V100 GPU. Each model runs 20 epochs with 5 early stop count based on the average match score. Since the distribution of the training dataset, development set, and the test days may be different, simply learning from the training dataset and validating in the development dataset will decrease the generalization ability of the model. We combine all the provided training and the development dataset, then split them and a random 5-fold setting. Each layer of the pre-trained language model, every layer of the all layer of the pre-trained language model is frozen. We choose a 3-layer feed-forward network with dropout mechanism before each layer except the output layer. The hidden size of 3-layer feed-forward layers are 141. The dropout rate is set to 0.3. We use Eden as our optimizer. We use binary cross-entropy loss to train the model, and the match score is used as the performance metric. The learning rate is set to and the batch size is set to 16 to make sure the experiment result is reliable and comparable among different models. we fixed the random seed of the system. In addition, the random seed of the function that dividing the dataset into 5 folds is also fixed to make sure the input data of each training is no different. And here is the result of our experiment. As we can see from the table, both feature 1 and lex feature 1 and lex feature 2 have a contribution to the improvement of the performance of the model. Feature 1 makes more improvements than feature 2, which means the words containing spatial letters are often not important, but the word started with capital letters sometimes is not important too. Here is the final score of different pre-trained language models. As we can see from the table, Chao XLM-ROBERTA large achieved the best score. Best average score, as their ability to extract information from text is superior to BERT, and GPT-2 large achieved the lowest score. In addition, the performance of BERT is poor, as is a tiny version of BERT, and the number of the performance of BERT is smaller than BERT. We design an end-to-end transformer-based system that makes the sentence in slides as input and predicts the importance of the words in the sentence. That's all. Thanks for your listening.